2 for Spring 2023 walkthrough for the course MA 16010. Let's begin. Number 1. A particle moves along a straight line with the position function of s of t equals t to the fourth minus 7/3 t cubed minus 10 t squared. What is the acceleration of the particle? So, just as a reminder, the acceleration equals the derivative with respect to time of velocity, and velocity equals the derivative with respect to time of position. So that means that the acceleration is the second derivative of the position function. So let's go ahead and start by finding the first derivative, or the velocity. So v of t equals derivative of t to the fourth is 4t cubed minus derivative of 7/3 t cubed is 7t squared. Derivative of negative 10t squared is negative 20t. So now we just need to find the acceleration function to find the answer to this question. So let's take the derivative again. A of t equals derivative of 4t cubed is 12t squared minus derivative of 7t squared is 14t, and then the derivative of negative 20t is negative 20, giving us an answer of A. Number 2. Find g prime of 1 given g of x equals natural log of x to the fourth plus 3x squared minus 9. So for this one, we need to use chain rule. If there's anything other than x inside of the ln function, then we need to use chain rule, as there's a function inside of another function. So let's go ahead and start by finding the derivative of the inside. So the inside is x to the fourth plus 3x squared minus 9. We want to find the derivative of this. So the derivative of x to the fourth is 4x cubed plus derivative of 3x squared is 6x, and derivative of a constant is 0. Okay, so now we want to take care of the natural log part. The derivative of natural log of u equals 1 over u. So for this, we're going to put 1 over everything inside of the parentheses. So derivative of natural log of u would be 1 over x to the fourth plus 3x squared minus 9. So you might ask, why did we find the derivative in this first step? Well, we need to use chain rule and find the derivative of what we found earlier. So all we have to do is multiply this derivative that we found by this part that we just did right here. So it would be 1 over x to the fourth plus 3x squared minus 9 times 4x cubed plus 6x. So at this point, we can go ahead and plug in 1 right here to find our answer for g prime of 1. So 4 times 1 cubed plus 6 times 1 over 1 to the fourth plus 3 times 1 squared minus 9. Let's simplify this. This first term is 4 plus 6 is 10, and then 1 plus 3 minus 9. So 1 plus 3 is 4, minus 9 is negative 5, so that'd be 10 over negative 5, which gives us an answer of negative 2, or C. Number 3. Find f prime of 4 if f of x equals 3x squared times the square root of x squared minus 1. So for this one, or minus 7. There was a transcription error earlier when I rewrote this exam. So for this, we see that there's one function times another function. So when we do this, we want to use something called product rule. Again, as a reminder, product rule is g times h prime plus g prime times h. So if we label this first part g and the second part h, let's go ahead and find g prime and h prime because we already know what g and h is. So g prime equals the derivative of 3x squared, which is 6x. H prime equals the derivative of the square root of x squared minus 7. So for this derivative, we have to use chain rule because there's we have the whole thing to the 1/2 power. So let's go ahead and start by finding the derivative of just the square root. That would be 1 over 2 square root of x squared minus 7. Because there's something under the root other than just x, we need to find the derivative of the inside. So the derivative of the inside, which is x squared minus 7, equals 2x. So we just need to multiply this by 2x. Again, that's chain rule. If we simplify that, we get x over the square root of x squared minus 7 because the 2's from the numerator and denominator cancel. Now, we just put it all together and we can say that g, so 3x squared, times h prime, which is x over square root of x squared minus 7, plus g prime, which is 6x, times, I'm running out of a little bit of space, so let me move something real fast. We want to do it times h, which is the square root of x squared minus 7. So this right here equals f prime of x. Now, at this point, we can go ahead and plug this into our calculator, or not into our calculator. We can go ahead and plug 4 into this function. So f prime of 4 equals 3 times 4 cubed over, it's getting really, really tight, sorry about that, 4 squared minus 1 plus 6 times 4 times square root of 4 squared minus 7. If you plug all of this into your calculator and simplify, you will get 136, or E. Number 4. Identify the relative local maxima of the function shown in the graph below. So what's really fun about these graph problems is it's really, really easy to see where the local maxima and min are. You just look for the little peaks. So you look for peaks for local maximums and dips for local minimums. So in this case, we can see that there is a local max here, here, and here. If we label those points, we can see that this farthest one on the left is at -4, 2. The one in the middle is at 0, 4. And the one on the right looks like to be 3 and 5. So if we look at our answers, that gives us B. Number 5. The radius of a sphere changes at a rate of 2 inches per second. What is the rate of change of the surface of a sphere in inches squared per second when the radius is 3 inches? The surface area of the sphere is given by the formula S equals 4 pi r squared. So when they're asking the rate of change of something with respect to another thing, that is something called a related rate. When we do related rates, we need to use implicit differentiation to find our answer. So again, they are asking for the rate of change of the surface of the sphere, which translates to S prime. So let's go ahead and take the derivative of this given thing. You would get S prime equals the derivative with respect to t of 4 pi r squared. Now, we notice that none of these terms are with respect to t, which means that we have to use implicit differentiation. So the first thing we want to do is pull out our constants. Our constants are 4 and pi. So we have 4 pi times the derivative of r squared. Now, if you take the derivative of r squared, it basically implicit differentiation. We treat it like a normal derivative, and then we just add a dr over dt in this case. So that would give us 4 pi 2r, because the derivative of r squared would be 2r, dr over dt. Again, because we do not know what the radius function is in terms of t, so we have to include a dr over dt term. So from this equation, we can basically solve for the rate of change at this point. We know the radius and we know the rate of change of the radius. Both of those are given in the problem. So let's go ahead and plug in numbers. We have 4 pi times 2 times the radius is asking when it is 3 inches. So we're going to plug in 3 here. And then dr dt, the radius changes at a rate of 2 inches per second. So we're going to plug in 2 here. So let's go ahead and multiply this out. 4 pi times 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12. Simplify that down, it would give us 48 pi, or an answer of D. Number 6. Given x squared y plus 2x equals 6e to the y, use implicit differentiation to find dy over dx at the point 3, 0. So, again, implicit differentiation. We do not know how y is as a function of x. So anytime we take a derivative of y, let's say we take the derivative of y with respect to x here. Rewrite that real fast. Derivative with respect to y, we would get dy over dx times 1, with that 1 being the derivative of y, which would just be 1 if you were to take it with respect to y. So knowing this, let's go ahead and solve the problem. Let's rewrite it. X squared y plus 2x equals 6e to the y. If we look at the left-hand side, we can see that this part right here is one thing times another thing, which means we have to use a product rule. So as a reminder again, product rule is g prime times h plus g times h prime. If we label x as g and y as h, let's go ahead and find g prime and h prime. G prime equals the derivative with respect to x of x squared, which is 2x, and then h prime equals derivative of y with respect to y, which again, from earlier up here, we can see is just dy over dx. Now, I'm going to move this to the side a little bit so it doesn't get in the way. We can go ahead and rewrite this with the derivative of this first part. This derivative of this first part would be g prime, so that's 2x times h from this, so h is y, plus g is x squared times h prime, which is dy over dx, plus we want the derivative of this. This is super simple. It's with respect to x. Derivative of 2x is just 2, equals, and then this last part right here, we have a constant. That will just be super simple. We take out the constant. So 6. Derivative of e to the y is e to the y, and then times dy dx, again, because we don't know how y is in terms of x. Now, we want to move all of these dy and dx's to one side so we can isolate them. So if we do that, we would get 6e to the y dy over dx minus x squared dy dx equals 2xy plus 2. Now let's go ahead and take out the dy dx. dy dx, 6e to the y minus x squared equals 2xy plus 2. Divide it out to get dy dx by itself, and we would get 2xy plus 2 over 6e to the y minus x squared. Now it's asking at the point 3, 0, so we go ahead and plug in 3 for x and 0 for y. So that would give us 2 times 3 times 0 plus 2 over 6e to the 0 minus 3 squared. So I'm running out of space again, so I'm going to move this a little bit. And so the top would be, this would be 0 because it's y 0. The top would just be 2 over 6 e to the 0. E to the 0 is 1, so 6 times 1 is 6, minus 3 squared is 9, so we get 2 over minus 3, or negative 2/3, or an answer of C. Number 7. Find the largest open intervals where h of x equals x to the 5th minus 15 over 4x to the 4th is decreasing. So when we're looking for decreasing, we are looking for where the derivative is less than 0. So let's go ahead and find the derivative of this. So h prime of x equals x to the fifth, derivative of x to the fifth is 5x to the fourth, minus derivative of 15/4 x to the fourth is 15x cubed. Now, let's go ahead and find our critical points where it would be 0, because anywhere that point where the first derivative equals 0 is where we'll be changing from decreasing to increasing, or vice versa. So let's go ahead and set h prime equal to 0 and solve for what x is. So I see a common term of 5x cubed, so I'm going to take out a 5x cubed. That would leave us with x minus 3 as the other term, this equal to 0. If we solve both of these, we would get that x equals 0 and 3. Now, what I like to do for these questions is draw a number line. I find it makes it a little bit easier to see what I'm doing. So let's go ahead and do that. Draw a number line. We're going to put our critical points on there, 0 and 3. Now, it's as simple as picking numbers in between each of these points to find where it's increasing and decreasing. So let's start with, let's say, -1, because that's super easy, just a little bit smaller than 0. So h prime of -1 equals 5 times -1 to the fourth minus 15 times -1 cubed equals 0, or not 0, sorry about, equals, this first term would be positive minus a negative, which would give us an overall term of positive. In this case, it's not super important to know what the exact number is. All we know is that all we need to know is if it's positive or negative. If it's positive, it's increasing. If it's negative, it's decreasing. So for this first part, we can mark this as positive as it is increasing. Now let's do a number in between 0 and 3. Let's do 1. So h prime of 1 equals 5 times 1 to the fourth minus 15 times 1 cubed. So this first term, 5 times 1 to the fourth, is 5, minus 15 is a negative number. So this middle portion right here is decreasing. And this last part right here, and let's use 4 because it's right above 3. H prime of 4 equals 5 times 4 to the fourth minus 15 times 4 to the third. That gives you a positive number if you were to plug all of those numbers into your calculator. So this last portion is positive. So we can see that 0 to 3 is where h prime is less than 0, or where it's decreasing, which gives us an interval of 0 to 3, giving us an answer of F. Number 8. Determine the interval on which f of x equals x cubed minus 7x squared is concave up. So when we're looking at concavity, we are looking at the second derivative. So if we want concave up, we want wherever the second derivative is greater than 0. So let's go ahead and start by finding the first derivative. F prime of x equals derivative of x cubed is 3x squared minus derivative of 7x squared is 14x. So let's go ahead and find the second derivative to find concavity, and it gives us f double prime of x equals derivative of 3x squared is 6x minus derivative of 14x is 14. Now, we want to find wherever this is concave up. So if we set the second derivative equal to 0, we will find the inflection point. The inflection point is where the function changes from concave down to concave up, or vice versa. So let's go ahead and set this equal to 0. If we solve for x, we would find that x equals 14 over 6, or 7/3. So let's draw our number line again. Put our 1 inflection point in the middle. Now, it's as simple as plugging in a number less than 7/3 and a number greater than 7/3 to see where the second derivative is greater than 0. So f double prime of, let's use 2, because 2 is a little bit smaller than 7/3 and 3 is a little bit bigger than 7/3. So let's use 2 for the left side, or less than 7/3. So f double prime of 2 equals 6 times 2 minus 14. That is a negative number. You would get -2. Again, when we're just looking at concavity, the number doesn't matter, only the sign does. So this left-hand side is negative. Just to double check, we could stop here. We would know that it would be concave up from 7/3 and up, but let's go ahead and check the other one anyway. F double prime of a point a little bit bigger than 7/3, we're going to use 3, equals 6 times 3 minus 14, which equals 18 minus 14, which is +4. So this would be a positive number, and we can see that from the right side, our number is greater than 7/3, it's positive. So if we draw that on our number line, we can see that this orange region is concave up because the second derivative is positive, giving us an interval of 7/3 to infinity, or an answer of B. Number 9, find the inflection point of y equals x cubed plus 3x squared plus 2. We just talked about concavity on the last question. Again, the second derivative, wherever it equals 0, is the inflection point. So let's go ahead and start by finding the first derivative so we can find the second derivative. So the first derivative, y prime, equals derivative of x cubed is 3x squared plus derivative of 3x squared, that's 6x. Derivative of a constant is 0. So let's go ahead and find the second derivative. Y double prime equals derivative of 3x squared is 6x plus derivative of 6x is 6. Now to find the inflection point, we're going to set the second derivative equal to 0. So let's do that and solve for x. So 6x equal to -6, x equals -1. So we have one inflection point at x equals -1. Now it's asking the exact point, so we just need to plug this number back into the original equation to find the y coordinate. So y equals -1 cubed plus 3 times -1 squared plus 2. So that's -1 plus 3 plus 2, which gives us 4. Putting those two together, we have a point, an inflection point of -1, 4, or an answer of F. Number 10. Find the x value at which the absolute maximum of y equals x cubed minus 12x occurs on the interval of -3 to 3. So when we're given an interval, not only do we want to check using what the maximum is using the second derivative test or the first derivative test, we want to make sure we check the edges because the edges might not be caught by the derivatives. So let's first start by finding our critical points using the first derivative. So the first derivative of the function here would be derivative of x cubed is 3x squared, derivative of -12x is -12. We set that equal to 0 to get our critical points, or where our max and mins could be, and we can take out a 3, so we get x squared minus 4 equals 0. I highly recommend looking into differences of squares. This first term would be a square, and this would be a number also squared. This is really common in factoring. You would get 3 times x plus 2 times x minus 2 from those two equals 0. From those two, we would get that x equals -2 and +2. Now, we know that the maxes and mins can be at these points, but also, again, we need to check the edges. The easiest way, I think, to find the maxes and mins on these interval questions is to just take these critical points and the ends the ends of the interval and just plug them back into the original equation and see which one's the min or max. So let's go ahead and do that. Let's start with the critical points we found. Y of -2 equals -2 cubed minus 12 times -2. That would give us -8 plus 24, which equals 16. Now let's do y of 2. Y of 2 equals 2 to the third minus 12 times 2, which gives us 8 minus 24, which equals -16. Again, we have to check the edges, so let's do y of -3 first. Y of -3 equals -3 cubed minus 12 times -3, which equals -3 squared is -27. Plus 12 times 3 is 36, which gives us 9. And then y of 3 is 3 cubed minus 12 times 3, which equals 27 minus 36, or -9. So these are all of our critical points or places there could be an absolute maximum, essentially. So if we look at the numbers, we see that this first one is the absolute max, meaning that we're looking for the x value. So that means that the absolute max occurs at -2, which gives us an answer of F. Okay, 2 more questions. Number 11. The function g of x equals 2x cubed minus 15x squared minus 30 has a relative/local maximum at which of the following x values? So for these ones that just ask without an interval, the easiest way to do this is with the first derivative test or the second derivative test. For this one, I'm going to be using the second derivative test. So we need to start by finding the first derivative. The first derivative, so g prime of x equals derivative of 2x cubed is 6x squared minus derivative of 15x squared is 30x. Derivative of -30 is 0. So let's go ahead and find our critical points here. Our critical points are, if we set it equal to 0, we can take out a 6x. If we solve this, we get that our critical numbers are x equals 0 and 5. So let's go ahead and draw this on our number line right here. We have 0 and 5. Now let's use the second derivative to find concavity. So g double prime of x equals derivative of 6x squared is 12x, and then derivative of -30x is -30. Now we just plug these 2 points in. So if it's concave up, which is my little smiley face, we have a local min, and if it's concave down, we have a frowny face, which is a max. So g double prime of 0 equals 12 times 0 minus 30, which equals -30. So this is negative, which means we are concave down. And we're going to go ahead and check the other one. G double prime of 5 equals 12 times 5 minus 30, which is positive 30. So we are concave up at 5. So we have a local maximum at 0 because our concavity, again, not F prime, G double prime of 0 is less than 0. Because it is a negative number, we know that at that point, the function is concave down, which gives us a local maximum. So again, our local maximum is at 0, which gives us an answer of B. Number 12. A boat is pulled into a dock by a rope with one end attached to the front of the boat and the other end passing through a ring attached to the dock at a point 12 feet higher than the front of the boat. The rope is being pulled through the ring at a rate of 3 feet per second. How fast is the boat approaching the dock when 15 feet of rope is out? So luckily we were provided with this very, very, very beautiful picture. So Let's go ahead and label some of the numbers we know. We know that the dock is 12 feet higher than the water, so this distance right here is 12 foot. And then we want to know how fast the boat is approaching when the rope is 15 feet. So this right here, this distance right here is 15 feet. Now, it's asking the rate of the boat with respect to the rate of the rope being pulled. Because we're relating one rate to another, we have a related rate problem. Now, this is really, really common. This is with the triangles, it's very similar to the ladder problems. And I saw a baseball diamond on one of the other ones. But essentially, we're going to use Pythagorean theorem to set up this related rate. So if we label this leg C, this leg A, and this leg B, we know that Pythagorean theorem is a squared plus b squared equals c squared. Now, we are trying to find the rate at which the boat approaches the dock. This would be this leg right here, or the B leg. So let's go ahead and isolate B. So b squared equals c squared minus a squared. Now, I'm going to go ahead and take the square root. That would be b equals the square root of c squared minus a squared. Now we're trying to find the rate, so now we have to take the derivative of this because b is the length, but we want the rate. So we need to take it with respect to time. So if we take the derivative of b with respect to time, it would be db over dt equals d over dt of c squared minus a squared. Now, we know what a squared is. It is a constant. The dock is not going to be any lower or any higher than it is in the given problem. So we can go ahead and plug in 12 for that a squared value. So if I rewrite this, it would be db over dt equals d dt square root of c squared minus a squared. So a is 12. 12 squared is 144. Now, if we take the derivative of this, we don't know what c is as a function of t. So we can take that c as a normal derivative, but when we do, we have to tack on a dc over dt. So let's go ahead and find the derivative. This one's a little bit tricky because it involves chain rule as well. So if we find just the derivative of the square root, we would have, if we have a derivative of a square root is this, would be x to the 1/2 minus 1 times a half, which gives us 1 over 2x to the 1/2. So if we do this, we would get 1 over 2 square root of whatever is inside the square root. That's c squared minus 144. Again, chain rule because there's something inside the square root other than an x or a constant, so we need to take the derivative of this inside stuff. If we take the derivative with respect to t of this inside stuff, so c squared minus 144, we would get the derivative equals 2c dc dt, again, because we don't know what c is in terms of t, so we need to use implicit differentiation and add that dc over dt term. So we multiply this with what we found earlier, times 2c dc dt equals db over dt. Now, we can go ahead and plug in all of our numbers. So if we plug in our numbers, dB over dt equals 2 times, what is C? Well, C is the length of rope. We are looking when 15 feet of rope is out. So that would be times 15 times dc dt. We know that the rope is being pulled at a rate of 3 feet per second. So times 3 over 2 times 15 squared. 15 squared is 225 minus 144. Let's go ahead and simplify a little bit. These two cancel. Let's see, 15 times 3 is 45. So 45 over square root of 81, that equals 45 over 9, or a rate of 5, giving us the answer of E. 5 foot per second is the rate at which the boat approaches the dock.